Hi, welcome to this other tutorial in which we will start from the same surface than the one with patterning, and this time we will try to put some geodesical curves on it, and we will see that they have special characteristics, which is that we can make stripes of paper or wood then to cover the surface. So let's start from components that a small component I did and that will give you. I will just paste it here. And let's see what it asks. So there is a surface, we will import it. Again, as usual, we will just reparameterize it so that parameters go from 0 to 1. And we give it as an input. Then it asks for a point and vector direction. So for that we will evaluate one point on the surface with evaluate surface, and we will make it with a construct point with the coordinates 0.5 in x and y, so that it corresponds to the middle of the surface. And so now we have this point, we give it here, and now we need a vector, which is the direction in which the geodesic will be drawn. And in fact, we want to do like a cross geodesic because you will see that like we want to build a net of geodesics. So starting with 4 orthogonal directions. So for that we will make rotation of the vector u, which is one parallel vector to the surface around the axis n, which is the orthogonal normal, which is a normal vector of the surface, and with a certain angle. And here we will place 4 angles to make the cross. So we make a series which steps are half p, so that it is half a turn each time. And we want 4 directions, and we will say we want to start. We want to be able to choose the orientation, so we will have a slider which goes from 0 to 2 pi, so we just multiply it by twice pi, and so this gives the direction at the beginning. And here just one thing I think that we should do, yes, if it's too high, then 3.5p. Okay, no, maybe it should work, because like it's more than a turn, but it should land still in the good direction, maybe. And now we still need to put some accuracy. Okay, let's just put a number, but I will explain you what it is and how many maximum iteration we want. Okay, here we have the curves. So accuracy is that, in fact, how does it work? It's an approximation of geodesical curves. And as you could remember what we saw, what is a geodesical curve? It is starting from a point in a certain direction, and then it just tries to go as straight as possible. So what it does is, this component is, each time it moves the point in the direction, then it projects it on the surface, and when it's on the surface, then from here it continues to move it in the same direction, and again and again and again, over and over, so that it moves until it reaches the edge of the surface, or until it reaches the maximum iteration that you put here. So accuracy should be not too low, not too much, so you can check it that the points are spaced in a good way. And yes, so we have the first cross, and you could see here that we can change the direction of it, maybe with more precision. And now we will try to do again geodesical curves, which starts from a few points evaluated on this first geodesics, and that goes orthogonal to it. So maybe let's start to join the curves, because here it's 4 curves, so now we have only 2, and we will divide them. Divide curve in a certain amount. And now we want to evaluate again the surface so that we could rotate the tangent around the normal of the surface. So we need to find the surface closest point. From the initial surface. Like the big one. Points. And now we can evaluate the surface again on these new points. The surface with coordinates u and v. So we get the normal vector, and we will rotate the tangents. Rotate vector, so we want to rotate the tangent of the curve around the normal of the surface on this point with an angle of half a turn. This will give a new direction for another geodesic to compute. So we copy paste the component, and so it will start from this point with this vector, and the surface will still be the same. Okay, I hope it works. Not really. Yes, of course, the vector we also need to make it reverse. So negative or reverse, it is the same. And yes, we have too much elements by branch, sorry, so we just graphed it, both of them, and also this one. So that now when we place, here when we place 2 elements of in each branch, it will be associated with each element in this one, so that we give 2 directions, and it could get in the 2 directions. Okay, so we just switch off this preview, and we have this net of geodesics. And as you could remember from the introduction, as it is not a developable surface, if you measure the angles between the geodesics, then you will see that it is not always 90 degrees. So it is 90 degrees at the beginning, but then there is a deviation because of the curvature of the surface. Okay, let's do this thing with stripes of paper or wood. So we will again join the curves that are going out of it, because each time we have 2, because one is going in one direction, the other one is going in the other direction. So let's make just 1 out of them. And now we will evaluate them on each point. Let me think, I don't know. Yes, okay. So we can just explode the geodesics, which are again approximation of geodesics, so it is polylines. We explode them, and then we will try to evaluate the tangent of each curve on these points. So we do evaluate, no, sorry, first we do curve closest point, so that we can get from these points to these curves the parameters to evaluate them. And now we can make evaluate curve. with these parameters and these curves. So we get again the same points that we already have, but this time we have the tangents. And now we want to rotate again the tangents 90 degrees around the normal vector of the surface on each of these points. So I think this time I can just make a copy-paste of the surface closest point and the evaluate surface. And I can also copy-paste the surface so that it's not too messy. By the way, if you know where it's coming from, you can just make hidden wire. So here, wire display hidden, or just type right click and then WH. Okay, so we evaluated each of these points, and that is not a good point. So these points we want to evaluate the surface with, so that we get the normals. Let's not graphed it this time. And we will rotate these tangents around. Again, sorry, I will copy paste rotation of half a turn, and graphed of the tangent vector around the normal vectors of the surface. And now we can build lines on these directions from the initial points and with a certain length, which will make us possibility to make a loft and then to have some stripes. That should be on the middle of the line, but yes, it is just an approximation. Okay. So here we have an approximation of like a how to call this, like some covering of the surface with stripes, which follows the geodesical curves. And it has the advantage that with these specific curves, the torsion in each stripe is very low. It's not totally developable, but it is almost developable. And the fact that the stripes are not too large makes that it is possible for the tolerance of the material to absorb this very small torsion and to build this shape. And maybe we can just check what happens if we set again the surface and if we change it a little bit. See how it behaves. And you see that if it's really a lot of deformation, the geodesics are going to be really a lot distorted and not follow too much straight line in projection, but just follow a straight line in the reference of the surface. Okay, we'll stop this for now, but you can see that it is implementation of geodesics that could be useful or could be a start of a design maybe. And if you want to use it, don't hesitate to start from the components here. And again, it's a very simple one. It is just iteratively, why it is a C component, it's just because we need an iteration so that we can approximate step by step the direction of the geodesic. All right, see you for the next one.